All right, so we're going to be graphing transformations today. So let me, on your graph paper, let's draw a triangle. So our triangle is going to start out at 1, 1, at 1, 4, and at 3, 1. And for simplicity, we'll label it A, B, C. And I was going to show you a few things that you're going to be working on in today's investigation, just to give you a heads up so you know what you're doing. The first thing we're going to do is we are going to reflect this triangle. We're going to reflect it, but we got to reflect it a special way. We're going to reflect it across the x-axis. Okay, so our x-axis is right here. So we're going to reflect it across. Now, a reflection is a mirror image. All right, so what that literally is going to mean is we're going to flip this triangle over the x into a new location. All right? So when I reflect it, notice my points are going to be the exact opposite across the x. And notice my new triangle, which I'll indicate with these little lines, they're letters, its points are exactly opposite of what it was. Okay? So that is a reflection. My A, instead of being at 1, 4, is now at 1, negative 4. My B, instead of being at 1, 1, is at 1, negative 1. My C, instead of being at 3, 1, is now at 3, negative 1. So I just mirrored its shapes. I can also reflect this one across the y-axis. Now I could do the y-axis as well. So let's reflect it across the y. I'm just indicating my points. Notice now my A, instead of being at 1, 4, is at negative 1, 4. Instead of my B being at 1, 1, it's at negative 1, 1. And now my C is at negative 3, 1. So all I did was flip the places. Now I flip my triangle across the Y the second time. Questions on reflections? Any questions on reflections? Does that make sense? All right. Let's try rotations. Put the triangle in the same place. You can do any shape that you're told to. Okay? Now, a rotation. Let's rotate this triangle 90 degrees to the right. Now, rotations are the ones that can be the trickiest for people. So let's rotate this triangle 90 degrees, 90, to the right. And we're going to rotate it on the B. So point B is not going to change. The rest of the triangle is going to change. So from B to A is how many units? 1, 2, 3, right? I'm going to change the color so it doesn't look as confusing. So let's go from B, 1, 2, 3. And here's our A. Okay? Now, between B and C is 2 units. 1, 2. So now my C is going to be 1, 2. Here's my C. Now I rotated my triangle 90 degrees. I turned it around the B, right? I can also rotate, I'll go back to red, rotate it 90 degrees, rotate my triangle 90 degrees about the origin. Okay, about the origin. And when I do that, when I rotate it 90 degrees about the origin, now I need to go to the other side here. So let's rotate it 90 degrees this way, but it's going to be about the origin. So it's going to be turned, and it's going to be on this side. So we'll start with the B again. My B is going to be right here. All right, so where's my C going to be if I turn it this way? Is my C going to be here, or is it going to be here? My left hand or my right hand? My left hand, so yes. So here's my C. And then A is going to be straight across from my B. 1, 2, 3. 1, 2, 3. Okay? Here's my A. Okay, and now I just turn my triangle onto its side about the origin. So if it says about the origin, you're putting your triangle in a different quadrant. Okay? It's not actually touching your original triangle. It's in a whole new quadrant now. Okay? Now, one way you can make this easy on yourself, you could do it the way I did it, or you can actually take a piece of paper and draw the triangle, like if you got a thin piece of paper like tracing paper and you can see through it, and you can draw the exact shape of the triangle and turn it physically and then figure out where it would be on your new sheet. That's another way you can do these. All right. There's more transformations to come. We got 2 more to talk about before I talk to you about this. Oh, by the way, I forgot to mention something here. 2 terms. Write these 2 terms down. I'll tell you what they are. Positive rotations and negative rotations. Positive rotations are counterclockwise, just so you know, and negatives are clockwise. Let's see, yes, so the yellow one would be a negative rotation, and the second red one I drew would be a positive rotation. All right? Cool? All right. Bless you. Translations. Remember, a translation is a slide. All right, there's lots of ways we can say translations. But let me draw a triangle. Show a translation of 6, 2. Okay, so what does that mean? Bless you. We're going to slide this triangle 6 places to the right because my 6 is positive, that's the x, and 2 places up because my 2 is positive. So let's take each and every point. Let's go 6 to the right. 1, 2, 3, 4, 5, 6, and then 2 up. We'll call this one A. Now this one, we'll call this one B. 1, 2, 3, 4, 5, 6, and 2 up. 1, 2. I didn't mean to make that dot. We'll call that one C, or B, I mean. Since it's my new one, I'll label it. And my C, 1, 2, 3, 4, 5, 6, and 2 up. I translated my triangle 6, 2. Every point went 6 places to the right and 2 places up of my original triangle. Now, the graph paper I have on the screen, remember, is the exact same one you have. Give me a second to catch up with that. That's called a translation. Okay? I moved everything to a different place by moving it 6 to the right and 2 up. So you just follow the coordinates, what it tells you to do. That's 6 right, 6 to the positive, and 2 positive on the y. All right? Does that make sense? Translations are one of the easier ones. I think rotations are probably the hardest. All right. So far, all 3 of these things that we've done are called isometries, which basically means despite all the stuff we did to them, we slid them with the translation, we rotated them, we reflected them, they kept their same shape, right? The same size and shape. They remained, the term for that is they remained congruent, right? We did all those things, but they still remained congruent. So we didn't alter them too much. Now, we're going to move on. Instead of isometries, which is a fun word to say, I want to say it, isometries. Now we're going to move on to something totally different, and these are called similarity, the right word, similarity transformations. And these are called, similarity transformations are dilations and contractions. So we're going to dilate a shape and we're going to contract a shape. All right, so let me draw a shape. Making a really large rectangle. If I were doing this on paper, I'd do it on a ruler. That's a big rectangle. Let's contract this rectangle. Let's make it smaller. Okay? Think we can handle that? But let's write down the coordinates for each one of these. B is what? What is B? It's at 6, 4. C is at what? It's at 6 what?
-4.
Okay. D is
-6,
-6, -4. And A is at, I know I did that way off. I just realized that. Let's fix that. No wonder why I was so off. Here. A little bit better. Still, I'll keep going wide on that. C, A is at -6, 4. All right, so we got a large rectangle drawn, right, on your sheet. It makes a big rectangle, doesn't it? If you graphed it out like you're supposed to. Makes a big rectangle. we're going to contract it. Let's make it smaller. And we're going to also dilate it. We're going to make it bigger. I have room on it too. Okay, first let's contract it. So to contract it, to make our contraction, let's contract it by 2. So let's divide every coordinate by 2. Okay, so my contraction is going to be negative 3, 2, 3, 2, 3, negative 2, and negative 3, negative 2. And then I'm going to redraw it. So negative 3, 2, 3, 2. I keep doing that. Yeah. Put that in the wrong place. 3, 2, 3, negative 2, and negative 3, negative 2. This is my first one. So we can call this, notice I'm just using these little markings to show that this is a different drawing. See it? My rectangle is smaller now, isn't it? I contracted it by a scale factor of 2, because we divide everything by 2. Now, let's dilate this thing by a scale factor of 2 of the original rectangle. So now let's multiply everything by 2. Okay? So, my second one, we're going to dilate this one. It's going to be negative 12, 8. And this is going to be positive 12, 8, because I'm multiplying everything by 2. This is going to be 12, negative 8. And this one is going to be negative 12, negative 8. And now we can redraw it. So 12, 8. 12's way out, and 8's way up here, right where I just wrote a bunch of stuff. And now we got negative 12. Oh, I don't have enough room. Darn it. Well, you know what I could do? Do you guys have the coordinates written down? Mm-hmm. Someone have the coordinates written down, so we'll redraw this right now. I'm going to go to a different screen is what I'm doing. You got them all written down, Nathan? Here we go. Ah, darn it. Just like. There, now I can get it off. Now I can get it all on there. Okay, what was the first one, Nathan?
It was
which one was A?
12, 8.
12, 8? 12, 8. Okay, what's the next one?
Negative 12, 8.
Negative 12, 8. What's the next one?
Oh.
That's okay, that one's right. What's the other two? Other two would be 12, negative 8.
Yeah.
Which is right here. And then negative 12, negative 8, which is right here. And you end up with a gigantic rectangle on your sheet, right? When you do it all, you have a huge rectangle on your sheet, right? Because you got 12, 8, you have negative 12, 8, you have 12, negative 8, and you have negative 12, negative 8. All right, so you see the difference between a contraction and a dilation? You see the difference between the two? Anybody? Crickets? Contractions, make them small, and we divided by 2, and then we doubled it to make it bigger, right? To make the dilation. So your job for tomorrow is to do investigation 5, which goes through, you just read through it and answer the questions. You're going to make you rotate and reflect and translate and dilate and contract shapes. All right? So you're going to need buku graph paper. Okay? Any further questions? Nada? No more questions? Okay. Darn it.